Namaste everyone, welcome to the class. Now in this class we are going to learn Laplace transform. The topic is Laplace transform 1. So let us begin. Laplace transform one. Now what we mean by Laplace transform? Let us first see its definition. This Laplace transform is very important in many field of engineering. So this is one of the important topic in your mathematics syllabus. Definition is if f of t is a function of t satisfying certain conditions, then the definite integral phi of s is equals to 0 to infinity e raised to minus st into f of t dt when it exists is called Laplace transform. Laplace transform of f of t, and is written as Laplace of f of t. This is the symbolic notation to define Laplace of f of t. So thus we will say Laplace of f of t is equals to 0 to infinity e raised to minus st into f of t into dt. So this is the basic definition of Laplace transform. Now we will see few problems to understand these definitions, okay, in a better way. We have given a function f of t. We need to find its Laplace transform. Then what we are going to do? We are going to implement this formula right hand side, that is 0 to infinity e raised to minus st into f of t dt. Okay, so let us solve few problems based on this definition. First I will take a very simple problem. The problem is, we will consider find the Laplace transform of f of t. The question is find Laplace transform of f of t where f of t is equals to t when t is between 0 and 4 and f of t is equals to 5 when t is greater than 4. So we have to find Laplace transform when f of t is defined like this. Now Laplace of f of t, if we see its definition, it is 0 to infinity e raised to minus st into f of t dt. Now a function f of t is defined differently for different interval, that is when t is between 0 to 4 it is defined as t, and when it is more than 4 it is defined as 5. So for that what we will do, we will split this limit integral from 0 to infinity as 0 to 4 and then 4 to infinity. So I will say that 0 to 4 e raised to minus st into f of t is t into dt plus 4 to infinity e raised to minus st into 5 into dt. Now the first part, here we are going to use integration by parts. Now in this chapter, integration, okay, you should know all the integrals, all the integration methods that you have learned in your standard 12th. Okay, so integration, if you have any doubt in that, or if you are not good in integration, then I recommend that first to go and learn integration and then solve this chapter. Now here I will use integration by parts. Integration by parts, you know, u into v method. For that, e raised to minus st exponential part is always come last, that is we treat that as v. So here using integration by parts, I will say this is equals to t into integration of e raised to minus st dt, where the limit for this e raised to minus st is 0 to 4, minus I have integration of, we will differentiate t, okay, so derivative of t is 1, okay, so in short I am writing derivative of t is 1 and integration, or else if you want you can describe completely, that is d by dt of t into integration of e raised to minus st into dt, this whole dt, and then I have plus 4 to infinity e raised to minus st into 5, so that 5 is constant, so let us take that 5 common, so integration of e raised to minus st dt. Now I will integrate, so this is t, integration of e raised to minus st is e raised to minus st upon minus s, limit is 0 to 4, then I have minus integration of, we differentiate, so we will get 1, we integrate it, so we get e raised to minus st upon minus s. Here also the limit is from 0 to 4, so limit is 0 to 4 into dt, then we have plus 5, we will integrate it, so it is e raised to minus st upon minus s, and here limit is 4 to not defined. Now this is equals to, let us write therefore here Laplace of f of t, okay, I have lot of space here, it is equals to t into, now I will use upper limit and lower limit, so it will become, so t upon minus s, let us write this outside, t upon minus s, here it is e raised to minus 4s minus e raised to 0, then minus plus I will write 1 upon s is outside, then again it is integrated and I will get e raised to minus st upon minus s, now limit is 0 to 4, and plus I have 5 here, 5 upon minus s we will say e power minus infinity, so e power minus infinity minus e power minus 4s. Infinity into s will be infinity, so I have not written infinity into s. Now let us see, this is equals to, now I will open the bracket, it is minus t into e raised to minus 4s whole divided by s, then plus e power 0 is 1, so it is plus t upon s, then here we have 1 upon s, let us write this as 1 upon s, inside we have e raised to, or what I will do, I will say minus 1 upon s square, that this I will take out, here e raised to minus st, so it will be e raised to minus 4s minus e raised to 0, then here I have minus 5 upon s, then e raised to minus infinity. Now e raised to minus infinity means 1 upon e power infinity, the value of e is 2.7 something, so when I take limit to infinity I will get answer as 0. So you can remember this thing, that e power minus infinity is 0, okay, and e power 0 is 1. So these two values you remember. So here e power minus infinity, so I will put 0 minus e power minus 4s. Okay, now I will open the bracket and simplify each and every term. This is minus t into e power minus 4s upon s. Then here I have plus t upon s. Then here I have minus 1 upon s square into e power minus 4s. Then minus minus I have plus 1 upon s square, and then here we have minus and minus, it is plus. Acha, one more thing, in the beginning itself, in place of t we are replacing 4 and infinity, all those things. So here when we replaced by 4, this t should also be replaced by 4. So here it is 4 upon minus s. Any other place we have t? No. So let us replace this t by 4. So this is 4, this is 4. Okay, so here it is 4, here it is 4 upon s. And now here it is minus minus plus, so it is 5 upon s into e power minus 4s. Now this first term, that is e power minus 4 e power minus 4s upon s, and this term 5 upon s e power minus 4s, I can add them, and what I will get? I will get 1 upon s e power minus 4s. Then here we have plus 4 upon s. Then here we have minus 1 upon s square e power minus 4s, and then we have 1 upon s square. So this is our final answer. If you want to simplify it further, you can take this e power minus 4s common. So if I take e power minus 4s common, I will get 1 upon s in one bracket minus 1 upon s square, then plus 4 upon s plus 1 upon s square. Okay, this is our final answer. Now let us check once again if everything proper, or again I am doing some mistake. Okay, yes, you can find the mistake again. Okay, upper limit minus lower limit. So here from the beginning itself, t into e power minus st. So here limit is for t, so this t cannot be outside, this t should be inside, so I should write t here. Okay, so when t is here, this 1 upon s to I can take out, but this I have to use here. It is t means 4 into, and here it is minus 0 into. So when I say 0 into, it will become 0. So this 4 upon s, this term 4 upon s term will not be there. So let us erase this. We have only minus. This 4 upon s term will not be here. 4 upon s term is not here. So I will not write this 4 upon s. So my answer is equals to plus, I say 1 upon s square. Okay. So better when you solve, just check your calculation once again. Maybe you have done some mistakes and you will identify it. Okay, so this is how we find Laplace transform using definitions. Okay, let us try to solve one or two more problems with the same concept. So let us take second question. Now second question is find the Laplace transform of f of t is equals to, so f of t is equals to given cos t for t between 0 and pi, and f of t is equals to sin t for t between pi to infinity. Means I can say that for t greater than pi. So for t greater than pi, okay, this can also be written as t greater than pi. So this is how our function f of t is defined. F of t is cos t for t between 0 to pi and is equals to sin t for t greater than pi. We have to find Laplace transform. So what I will say? I will say Laplace of f of t is equals to 0 to infinity e raised to minus ht into f of t dt. Now here 0 to infinity, I will say that 0 to pi e raised to minus st into cos t into dt plus pi to infinity e raised to minus st into sin t dt. Now again we have to implement integration by parts, but if you remember in 12th standard we have derived this kind of expressions and arrive at a formula. The formula we can use directly, so here is that formula. Okay, integration of e raised to ax into cos bx into dx, this is equals to 1 upon, here it is 1 upon a square plus b square. Now a is e power ax, so this is a, and cos bx, so this is b part, into e raised to ax. Inside bracket I have a cos bx plus b sin bx. So instead of doing any derivation, you can use this formula. Similarly, e raised to ax into sin bx dx, we can use formula 1 upon a square plus b square into e power ax. Here inside the bracket we have a sin bx minus b cos bx. Okay, so we implement this formula and we will get the solution. Now using this formula I can say that therefore Laplace of f of t is equals to, here 1 upon, now the value of a is minus s and value of b is 1, so here it will become 1 upon s square plus 1 is bracket into e power minus st into here a, that is minus s, into cos t plus b is 1, so it is only sin t, and limit is from 0 to pi, plus I have 1 upon s square plus 1 e raised to minus st minus s into sin t minus cos t, and here limit is from pi to infinity. So let us put these values. This is equals to 1 upon s square plus 1. Now in place of t we will put pi, so it will become e raised to minus s pi. Inside bracket we have minus s into cos pi plus sin pi. Then minus I will put 0, so it is 1 upon s square plus 1. This is e power 0. Now what is the value of e power 0? E power 0 is 1, but let us write e power 0 into e power 0 into, here it is minus s into cos 0 plus sin 0. So s into, here we have cos 0 plus sin 0. Now we have second bracket, so plus, here we have 1 upon s square plus 1, then here we have e raised to minus infinity, here we have minus s into sin t, so sin, it will become sin infinity minus cos infinity minus, we have 1 upon s square plus 1 e power minus s pi, here we have minus s into sin pi minus cos pi. So 1 upon s square plus 1 is common, so let us take out 1 upon s square plus 1. Now here e power minus s pi, and inside cos pi is minus 1, so minus s into minus 1, it will become s. Sin pi is 0. Then I have here minus e power 0 is 1, so I have 1 upon s square plus 1, then minus s into cos 0 is 1, so this is minus, and this is minus, so I will take minus minus plus, and in place of s we will write s, so it is s upon s square plus 1. Then here sin 0 is 0, so that we will not write. Then here e power minus infinity is 0, so infinity multiplied by anything is 0 only, so 0 minus, here e power minus s pi, and inside we have sin pi is 0, so this whole term is 0, and this is cos pi is minus 1, so minus minus plus 1. So finally I get, okay, here why I am writing s square plus 1, this is already we have taken out, so here I will write only s term, right, so plus s. So here it is 1 upon s square plus 1, s into e raised to minus s pi, and here 1 into, so inside bracket I will say s minus 1 e raised to minus s pi plus s. So this is our final answer of Laplace of f of t. So the problems are not difficult, only you have to understand how you are implementing the formula. Majorly you are getting integration by parts here, because one term definitely e raised to minus st will be going to be there, and the second term, if it is any function, then you are going to use u into v method. Okay, shall we see few more problems? Let us see one more problem, and then we will go to the next topic or next type of problems. So let us see one more problem. Here we will see a problem like f of t is equals to something different. If I check, okay, so let us take one problem. F of t is equals to cos t. for t between 0 and 2 pi, and f of t is 0 for t greater than 2 pi. Okay, so we have to find Laplace transform. So Laplace of f of t is equals to Laplace of f of t is equals to 0 to infinity e raised to minus st into f of t dt. So here we will split this into part 0 to 2 pi. It is e raised to minus st into f of t is cos t into dt, plus the second part is 0. So we have to implement this much part only. So this is e raised to minus st. We have seen the formula of integration. I will say that it is 1 upon s square plus 1, and here we have minus s into cos t, then plus we have sin t. Limit we will see it is 0 to 2 pi. This is equals to, now first here e raised to minus st is also there, 1 into e raised to minus st. Okay, so here it is, when I replace 2 pi, it is e power minus 2 pi upon s square plus 1. Here we put 2 pi minus s into cos 2 pi plus sin 2 pi, then minus here e raised to 0 divided by s square plus 1. Here s minus s into cos 0 plus sin 0. So this is equals to e raised to minus 2 pi upon s square plus 1. Here cos 2 pi is 1, right, cos 0 is 1, cos pi is minus 1, cos 2 pi is plus 1. So here I will get minus s, sin 2 pi is 0, sin n pi is 0. Okay, so you have to remember this thing, that sin n pi, learn this formula, that sin, here I will write sin n pi is 0 and cos n pi is minus 1 raised to n. So if you remember these two things, you can write for sin pi, 2 pi, 3 pi, 4 pi, like that. Okay, so when I say 4 pi, so minus 1 power 4 is plus 1. When I say 3 pi, then minus 1 power 3 is equals to minus 1. And here for any value of n, 1, 2, 3, 4, where n should be integer value, so for any value of n, I will get answer as 0. So this is the formula. Okay, let us erase it. Now here you have e raised to minus 2 pi upon s square plus 1, here I have minus s, plus this is 0, minus e power 0 is 1, so it is 1 upon s square plus 1, cos 0 is 1, so here again I have minus s, and sin 0 is 0. So finally I will say that you can see that s, this minus minus plus, so I will say s is common upon s square plus 1 is common, this I will take common. Here I have 1 remaining, and here I have minus s, so I have taken out, e upon s square plus 1 is also out, so 1 minus e power minus 2 pi. Okay, so this is your Laplace of f of t. Okay, so in this lecture we have understood the definition of Laplace transform, and we have solved few problems using this definition. Now as you see, using definition problem is little lengthy, so in our next class we will see some methods by which we can find Laplace transform in much easier way. So thank you for being with me. Okay, I hope you understand everything. Now if you have your standard textbook. From that textbook you can try few problems. If you will not get solution for any of the problem, just comment me. I will try to help you out. Thank you once again for being with me in this lecture.